So for this one, we've got to work out how many protons, electrons and neutrons there are in these different species, and we're given some bits of information and we have to fill in the gaps. We're told that we're talking about two isotopes of sulfur, so we're talking about the same element, they've just got a different number of neutrons and a different mass. So in terms of chemical symbol over here, but because we're talking about sulfur, we can put that there. We don't know what the mass is at the moment, so we leave that there. What we do know, however, because we know it's sulfur, we should be able to work out how many protons there are, because the proton number is the same as the atomic number in the periodic table. So if we have a look at the periodic table and we look at sulfur, which is over here, we see that the atomic number is 16, which is this low one. This is the one that increments by a single digit each time, so you got 13, 14, 15, 16. So that's the atomic number, and that there is the relative atomic mass, which is a weighted mean mass of all the isotopes of sulfur. So the one we're interested in is there. We're interested in this the atomic number, which is also known as the proton number, and that will give us the number of protons there are. So what we can fill in is the number of protons in both, because they're both sulfur, so they're going to have the same number of protons. The number of protons in an element doesn't change, because if the proton number changes, then the element then changes. So the proton number is the same. This has got no charge on it, so therefore the number of protons and number of electrons are the same. It's neutral. So the protons are positive, the electrons are negative, and they cancel each other if they're the same, and they become neutral. And now we can work out the number of neutrons, because the number of neutrons plus the number of protons will give us the mass number, which is this number here. This is the mass number. And that equals the protons plus the neutrons. Now, so what we've got there is 16 plus whatever the neutron is equal to 34. So our number of neutrons are 18. There's 18 neutrons there. We have nearly worked it out now. There's only one thing we've got is, with this second one, what we've got is we've got more electrons there than we've got protons. So that means we're going to have an overall charge on our ion of 2-, because of these electrons. There's more electrons than there are protons, so it's going to be negatively charged. So it's going to have a charge there of 2-. The mass number, like we've already said, is the number of protons plus the number of neutrons. So we've got the number of protons here, we've got the number of neutrons here. So in this case, it's going to be 32. It's a different isotope. You see here it's the same element. It's going to undergo the same chemical reactions, but the mass number is different because it's got a different number of neutrons. And I guess what we could also do is we could maybe put the atomic number down there in the lower place there. So we've got the atomic mass there, atomic number there, and we've filled in.